Hello viewers, this is Dr. K. RAJASHEKAR from Excellence IAS. In this video, we are going to talk about Nobel Prize in Chemistry for 2023. This Nobel Prize is given to scientists, 3 scientists specifically working on quantum dots, discovery and synthesis of the quantum dots. Before talking about what are these quantum dots, let us see a few facts about chemistry Nobel Prizes. So far, chemistry Nobel Prizes have been given 115 times since the launch of it in 1901. So far, 8 women have received Nobel Prizes. Friedrich Sanger and Barry Sharpless have received Nobel Prize in Chemistry twice. 1958 and 1980 for Friedrich Sanger. He was the one who worked on protein like insulin structure, nucleotides, etc. And Barry Sharpless received Nobel Prize in 2001 and 2022. I'm not sure if you are ever aware about this interesting fact about Curie family. Together they have received 5 Nobel Prizes. Curie received it once in chemistry and physics, and her husband and her daughter and son-in-law, all of them have received Nobel Prizes. So leaving out 1 Nobel Prize in physics for Curie, remaining Nobel Prizes were given in chemistry. So they can be called as Nobel family, Nobel Prize family. Okay, probably you are aware, during the Nobel Prize ceremonies, they are given 18-carat gold medal, a diploma and a cash prize of $1 million, which roughly is about 8 crores Indian rupees. That's a huge amount of money, right? Worth to do that amount of research. Next, let's see what are quantum dots. So this year we have seen the prize going to the quantum dots in chemistry. What is so special about quantum dots? What are they? So these are made up of nanocrystals. These quantum dots are made up of nanocrystals of a size of 2 to 10 nanometer. How much is a nanometer? 10 to the power minus 9 meters. It's really tiny. We can't see it with our eyes. And this is where things exist at the scale of atoms. So basically we are zooming to the fundamental thing about matter. That is at the scale of atoms. That's how small they are. And they are made up of what is called semiconductor particles. What are semiconductors? Semiconductors are those materials which are inorganic in nature and that are between conductors and insulators. So they have intermediate properties to both conductors and insulators. Here they use something like silicon, germanium, etc. Even nowadays graphene-like particles are also used in creating quantum dots. The speciality of them that they exhibit quantum properties. For example, light emitting properties of them are unique. They show light, they emit light, or they fluoresce when a light falls on them, like UV light. If you throw UV light on the quantum dots, they start producing different kinds of colors based on their size. Let me explain that with an image here. So here we are seeing VIBGR colors. So we have violet on the left and we have red on the right. And do you know, these lights are emitted by the same nature of quantum dots of different sizes. On the left hand side, we have, if you can notice here, the size is less. If you keep increasing the size of quantum dot, its color output changes. With increase in size, it is moving from violet color to the red color. Imagine roughly 2 nanometers of quantum dot may produce violet color, whereas something like 7 nanometers or 10 nanometers of quantum dot produces red color. So here the wavelength of the light is longer, much longer. The wavelength of the light is much longer, and with increase in wavelength, generally what happens? Energy and frequency decreases. That is what we normally notice here. So with increase in size, we notice here they have a different colored output. So what scientists could do here? Scientists could play with the size of the quantum dots to define what kind of color they want to see. Right. So next, Nobel Prize specifically, if you see what these scientists have independently contributed to this field. So we have Maungi Bawendi, who is associated with MIT, Massachusetts Institute of Technology in USA, and Louis Bruce, who is at Columbia University in USA, and Alexei Ekimov, a Russian scientist who is working for nanocrystals in technology located in New York. What they have done, Russian scientist Dr. Ekimov is the first person to discover quantum dots, produce quantum dots. So he's a discoverer of quantum dots. And Bruce in 1983 along with his colleagues has created or manufactured, or they call demonstrated, the features of quantum features of these quantum dots in fluids, in liquids. Okay, so initially these were produced in glass. So initial discovery happened with that, but later these properties have been demonstrated in the liquids by Dr. Bruce and team. And then Dr. Bhavindi is actually perfected the process of chemically manufacturing these quantum dots. Okay, so together these people have made quantum dots possible and made their production and utility that we are going to see, we are going to discuss possible through their great research. Okay, how are they useful and where are they useful to us? Quantum dots are finding applications in many areas, like including biomedical, in biomedicine or in medical field. They can be used in imaging human body, identifying any abnormalities in our body. For example, they can precisely locate a tumor. They can precisely locate a tumor or a cancer cell in the body, and also they can help in guiding the drug to a particular target site, because in cancer the biggest problem is side effects, because chemotherapy or radiation therapy, those drugs or energy sources can damage healthy cells as well. So if we can drop the drug specifically at the target cells, then we can minimize the side effects of that, which can be done with the help of quantum dots. And then today we are seeing many screens, much brighter screens which are even energy efficient. They consume less power, but they are able to produce more light output. Those bright TV screens, like most famously known things in the market at the moment are QLED screens. They are made up of quantum dots. So quantum dot based LED screens, much brighter, more energy efficient. And also they can be used in improving the absorption and electricity production by photovoltaic cells, or they are known as PV cells. Where do we see them? In solar panels. So photovoltaic cells in solar panels can also be created using quantum dots. Like that, quantum dots are found in applications, variety of applications. It could be medical field, it could be in electronics, it could be in energy production, it could be in sensors. Even scientists are using them in counterfeiting, like currency, etc. To avoid any counterfeiting of that, quantum dots are also being used. Like that, quantum dots are found applications in great amount of areas. These scientists with this amazing work definitely deserve Nobel Prize this year. Okay, next we'll see in the exam point of view what to focus on. In the exam, they can ask questions on things like what are quantum dots, nature or properties of quantum dots they can focus on. Okay, so what are quantum dots? Okay, size range of quantum dots, kind of materials that can be used or are being used in quantum dots. Okay, and another very important feature that probably we need to remember here is how the color output is changing with respect to the size. Okay, if size actually becomes bigger, we'll see the different color output. Let's say if they want to ask you something a bit more complicated, like why does it happen? It happens, they say, when you are constricting it, when you are actually reducing the size of the quantum dot, energy seems to be much higher. So when you are relaxing it, energy seems to decrease. It is something to do with confinement of electrons, restricting the electron movement. That is what is resulting in. So in case if they want to ask something a bit more complicated, this could be that. Otherwise, applications can be asked, like which of the following applications related to quantum dots. Such questions are very much possible. Hope this discussion is useful to you. Thank you.